call is now being recorded.
Okay. So let's look at the books that you need to have in your practical class. Okay, so we are going to split the practical class into two different sections. 3 experiments we are going to carry out in a virtual lab form, and another 3 we will just give you a video, then you will conduct the experiment, you will write the lab report. Okay, so basically 3 you need to have a hands-on section, and then for the other 3 you're just going to watch the video and then do lab report. Now for the 3 that you're going to watch videos and conduct lab report, you're going to need this book. Okay, so this is the ebook that you're going to use for report writing sections. Okay, the ones that you watch video only, don't need to do any hands-on experiment. You just watch the video and then use the data given, write lab report. So you're going to use this book for, okay, now let's go through the title. So you're going to have a 6 experiment in a SEM 1. First is the measurements and uncertainty, and then you will have a free fall and projectile motions, energy, rotational motions of a rigid body, simple harmonic motions, and standing wave. So the ones that you're going to watch video and write lab report, if I'm not mistaken, is the projectile motions, and then energy, and also rotational motions of a rigid body. Okay, I think we don't have the standing wave experiment if I'm not mistaken. And then for the other 3, where you're going to carry out hands-on experiments at your own house, is a measurement and uncertainty, and then free fall experiment, and also simple harmonic motions experiment. Okay, so 3 virtual lab, and then 3 video watchings and do experiment, okay, and do lab report. So this is the books when you're where you're going to refer to when you do report writing. Okay, so let's see. Okay, so the important things, I think you can watch it from this 2.3. Report writing, the things that you have to have in your lab report. So the report must be written properly and clearly in English and explain what has been carried out in the experiment. Each report must contain name, matriculation number, numbers of experiment, the title, date, and the practicum group. Okay, so basically, for a proper lab report, these are the things that you must have. Okay, so the report must also contains the following. So name, matriculation numbers, and a practical group. Okay, let's say this is your lab report. You write it on top of the report. Okay, so this is your name, and then your matriculation numbers, and your practicum group. And then the formal report start from experiment, the title of the experiment. Okay, so this is a title, the title of experiment. And then after that, you follow by this part. Okay, the report must also contain the following criteria. So start from the title, and then followed by the objective. Okay, followed by the objective, and then the theory. Now, theory in matriculation is very simple. What you're going to do, you just copy the theory from your lab manual. All right, you don't have to do your own research like what you have to do in a university. In university, you'll be given just the title of the experiment, and then you have to done the theory, the background research on your own. In matriculations, we let you copy it from your lab manual. Okay, and then the apparatus, you can also copy it from the lab manual. Now for the measuring apparatus, you have to write the range. Okay, the range and also the sensitivity. So for example, voltmeter, the range is 0 until 10 volt, and then the sensitivity is plus minus 0.1 volt. So I will tell you what is the meanings of sensitivity after this, don't worry. Okay, and then the procedure. Procedure, you have to change into passive sentence. Okay, the books given is in a statement, so you change it into passive sentence. And then observation is our result. Okay, observation actually is our result, where you put your table and also the calculation under this category. And then after this, you're going to write a discussion. So what do you have to include in your discussion? It's very simple. First paragraph, you give comment about the experimental results. Okay, whether your experimental result is acceptable or not, what is the errors, what is the uncertainty of your own results. And then you state 2 errors, 2 possible errors, and then 2 precautions that has been taken to overcome them. Okay, the errors that you found in your experiment, and then the precautions that you take to overcome them. So error usually is the second paragraph. Precaution is the third paragraph. Okay, so first paragraph is a comment on your results, the errors, and then your findings, your results, and then second paragraph, 2 errors, third paragraph, 2 precautions. And then at last is the conclusions. Okay, so conclusions, you just refer to the objective. Say whether the objective is achieved or not. Okay, if it is achieved, then you state the result. If it's not achieved, you also state your result and then give a brief explanation. Why is it not achieved? Okay, so no plagiarism is allowed. So what does it mean by plagiarism? Means that copy your friend's work. Okay, you are not allowed to copy your friend's work. You have to do your own writing. Don't worry about grammar though, because I don't look at grammar very much because I'm teaching science. I'm not your English lecturer. Okay, so what are we going to check is whether your scientific concept is correct, and then whether the format is correct, whether the result is okay, is acceptable or not. Okay, the way you write your lab report and so on. So try to do your own works because you're going to do it in your practical test, report writing test, and also you have to do it in your own university, okay, in your university. Now, in a university, okay, if you get caught in a plagiarism, what is going to happen? You are going to repeat the whole semester. Okay, you're going to repeat the whole semester because in university, once you're caught in a plagiarism, you'll be given 0 mark. So it is very important to do your own works. Okay, don't be afraid to try. Jangan risau. Okay, kamu cuba sahaja guna ayat sendiri, buat sendiri. Okay, jangan salin kawan punya lab report. Now, of course, students always tell me you discuss with your friends. Discuss doesn't mean that you will have a 100% same lab report. Okay, because you're still going to write your own discussion, you're still going to write your own result, you're still going to do your own calculations. Okay, now sometimes your friend might make some silly mistake. Once you copy your friend's work, then you can get caught easily because of those silly mistakes. Okay, maybe you just write the decimal place at the wrong positions, maybe you just round up at the wrong place, and so on. That is what I call silly mistake. So if you copy your friend's work, then you can get caught easily because of those mistakes. Okay, because of some mistake in a simple calculations, in a simple write-up, or maybe even some simple statement. Okay, your friends make some simple grammar mistake, you copy your friend's work, both of you make same mistake, then that is how we notice that you copy your friend's work. Okay, so you can reverse, you can ask, but write it with your own sentence because everyone's have different pattern. Okay, I would say pattern. So I can tell easily whether you do your own works or you copy your friend's work. All right, so don't plagiarize, don't copy your friend's work. Try your best. Okay, try your best. I won't scold you if you make a mistake in a lab report. Okay, I won't scold you if your grammar is not okay. Okay, I will just tell you where is the mistake, where is the part that you need to improve. And then the next one is a significant figure. Significant figure is very important in a physics report. Okay, actually in all scientific report because it tells the reader, okay, how many numbers, how many digits in your writing have a meaning. Okay, sometimes we round up the value because it's too large or it's too small. Okay, so after we round up, those 0 actually it doesn't carry any meaning. So what we want in a scientific report is a digit that carry meaning, okay, that contribute to its precisions. Okay. So this one I will discuss it in a bit. I will skip it first. Okay, so these are the rules. You can find all this information in your notes, in your lab manual. Okay, so uncertainty in measurements, I also have a note. And this is the part that you have to do in your first report actually. You copy, okay, you record the different readings and then you calculate the uncertainty. So this one, we'll go through it again in a bit. So I just shows you what you have in your lab manual, okay, the things that you can refer to in your lab manual. Straight line graph, I will keep it for next experiment, okay, experiment 2. Experiment 1, you don't need to sketch graph. So I will discuss it in your experiment 2, including how to do all these calculations, all this uncertainty, okay, delta M, delta C, and so on. Okay, then you will have your first experiment. Okay, so all these, we'll discuss it next week. Okay, so then we are going to have a first experiment. Now, first experiment, you don't need to refer to this lab manual. Okay, first experiment, you are going to carry out in your home. So we are going to move to virtual lab report now. So this is the second lab report that you need to have. Okay, so if you get it from your Feeboard, you go to page 24. Page 24 is for physics. Okay, so after that, you have a section 4 for biology. Section 5, I think, is for chemistry. So you go to page 24, okay, the page for physics. Then this is the manual for your first experiment. Okay, so for format, you can refer to the lab manual just now. Okay, the blue color cover. Okay, this it takes time to load. Okay, now this. Okay, so report format, you can refer to this manual, but then for the lab manual, for the procedure, you have to refer to virtual lab manual. So you have 2 different lab manual in this semester. Okay, I will tell you which one to use every week. Don't worry about that. Okay, just make sure you have both of them. So for first experiment, the experiment that you're going to carry out next week, okay, actually you can do it after today's class as well. Don't have to wait until next week. So first experiment is a measurement and uncertainty. Okay, so this is your experiment 1. So learning outcome, now this is your objective. Okay, this is your objective. So objective is a learning outcome. You refers to learning outcome, but of course you don't copy all this. Okay, you don't copy all this. So for objective, you just take these 2 statements. Okay, these 2 statements. So to measure length of various objects, that is your first objective. Second objective, to determine the uncertainty of length of various objects. So don't copy whole thing. Don't write at the end of this section, blah, blah, blah. Your objective start from to measure the length of various objects and to determine the uncertainty of length of various objects. Okay, so objective can be found in your manual, and then theory, you just copy everything. So measure some physical quantity is part and parcels of any physics experiment. So it is important to realize that not all measure value are exactly the same as the actual value. That is the reason why we take multiple reading in physics experiment, because of all this uncertainty. Okay, so this could due to error that we make during the measurement, or perhaps the apparatus that we use may not be accurate or sensitive enough. Therefore, as a rule, the uncertainty of measurement must be taken and has to be recorded together with the measure value. So this first experiment is just for you to learn what is the meanings of uncertainty. Okay, what is uncertainty? What is sensitivity? What is the difference between these 2 things? And why do we have to take multiple reading? Why do we need to get average value? Okay, so first is because the limitation as a human. All right, maybe our eyesight cannot reach a small reading accurate enough. And a second thing, because of the tool that we use. So some apparatus, for example, meter ruler, we can read up to 0.1 cm, but the accurate value might be 0.0001 cm. And that is one of the reasons why we need to have uncertainty in our reading. So the uncertainty of measurement depends on the types of measurement and how it is done. So for a measure quantity X, for example, if you measure with meter ruler 1 cm, then it comes with uncertainty 0.1 cm. So the measurements have to be recorded as follow. So anything that you measure with measuring apparatus, the reading must be recorded in this form. Okay, so for example, if you measure with meter ruler, then you get a reading 1 cm, you have to write it as 1.0. Now, why must I write this 0.0? Because it tells the reader what is the smallest value that can be recorded from the tool that you use. If you use meter ruler, the smallest reading is 0.1 cm. Therefore, the readings that you record must come with 1 decimal place. So 1.0 plus minus 0.1 cm. This is the uncertainty of the meter ruler. Okay, the smallest value that can be recorded. And then you put a bracket outside this value and come with a unit cm. So this is how you do a recording in your report writing. Okay, so anything that you measure with measuring apparatus. For calculated value, you don't have to include this yet. Okay, you don't have to include the uncertainty. But for measuring reading, for the things that you measure directly with apparatus, for example, you use weighting scale, you use voltmeter, you use meter ruler, vernier caliper, and so on, then it must come with this uncertainty. Okay, it must come with uncertainty. So the relative uncertainty of measurements is defined as, and therefore percentage of uncertainty is another thing that you must have in your report writing. Okay, you calculate percentage of uncertainty in your final reading. And this is a thing that tells us whether your reading can be accepted or not. Okay, so if the percentage of uncertainty is too large, then it means that your result is not very accurate. Okay, your result is not very accurate. So you write your report, you write your measurement, your data in this form, and then you calculate the percentage of uncertainty. Okay, single reading means you take the reading just one time. Repeated reading, you take it multiple times. Okay, and then you take the average value. That is the meanings of single reading and repeated reading, sorry. So all this you go through by yourself because it's your first experiment. So apparatus, you can just record it. Okay, you can just copy it from the books. Okay, just at the meter ruler. Make sure you put a bracket here and then come with the sensitivity. Now, sensitivity, okay, sensitivity is not the same as uncertainty, yeah? Sensitivity is the smallest readings that you can record, you can read from the tools. So for meter ruler, it's a 0.1, okay, plus, minus, or without plus, minus also fine because it's just a sensitivity, it's a 0.1 cm. Okay, it's a 0.1 cm. So vernier caliper, micrometer, screw gauge, later you refers to the website. You will have a QR code in this virtual lab manual. You scan it, you proceed to the website, and then you carry out the experiment. So sensitivity and uncertainty, they are not the same. Sensitivity, you put it in the apparatus. Uncertainty, you put it in the observation. Okay, we use uncertainty in observation. I will tell you how to do it. Don't worry about that. Okay, so you need 2 books. You just find any 2 books in your own room. I believe you have books in your house, right? Don't tell me, Madam, I cannot do this experiment. Why? Because I don't have any books in my house. I don't believe that. Okay, I don't trust you. So you get 2 books with different size. Okay, these 2 books must come with a different size. So it would be better if you take, for example, the exercise book from your secondary school. It's small enough, and then the textbook. Okay, so it's one big, one small. Okay, 2 with different length. So you need to measure the length in the first experiment. So the procedure. Okay, the procedure. So choose the appropriate instruments for the measurements of the lengths of the books. Okay, that's why I asked you to find the books with different length. And then the diameter of an oval object. So this object, you don't have to use a real object. It is a virtual object from a website. And then the width of the dumbbell handle. It is also the virtual object from the website. Okay, so this is a real object. Books is a real object. And then this two thing is a virtual object that it can be found in the website. Okay, so for task 1 until task 3, okay, you have to repeat the measurement for 5 times. Therefore, you need to record it in a table. So you have a 5 reading. Okay, you need to record at least 5 readings. So this is the length of the book. Okay, now what does it mean, this one? So you calculate the length of the book and then you put the uncertainty. Aha. Now, this table, you put it in observation. Okay, this table, you put it in observation. And then the uncertainty, you put it in the table. All right, table is in observation. Of course, you need to copy all this in your procedure first. Okay, and then in observation, you repeat this table. Okay, you repeat this table for object 1, length of the book, and then object 2, or oval object, object 3, the handle of dumbbell. So you have 3 tables in your observation. Now, how are you going to calculate it? So this one, for example, if you measure the length of the book is 10 cm, then you write 10 cm. Okay, so don't need to put cm because it's in the header already. Okay, so maybe the second time you repeat it. Okay, this is 10.0. The second time you repeat it, you got a 10.0 again. And then you repeat it again, you got maybe 10.2. Okay, you repeat one more time, maybe you got a 10.1. And then the last time, maybe you got 9.9. Maybe. Okay, this is just an example. So after that, you calculate the average value. Okay, which is known as a L with a bar on top of it. So average value, after you obtain this average value, now then you can proceed to this column, okay, this column. So how are you going to calculate this column? You use average value minus the measure value, okay, minus the measure value. So I think the average is around 10.1. Now this is just an example, yeah. So if your average value is 10.1, what are you going to do here? You use 10.1 minus 10. Then you're going to get 0.1. Okay, so if you got 10.1, then average value is 10.1. You minus the length in your first measurement, you obtain the values that needed in the first row. So it's 0.1. You just repeat for all 5 of them. But remember, if you look at the header here, it comes with a modulus. The 2 straight line here, it means modulus. So you are just going to record the positive value. All right, so even for a 9.9, so you use 9.9 minus 10.01, you're going to get negative 0.2, right? Don't write it as negative value. Okay, you record it as a positive value, 0.2. So 0.1, okay, so 0.1, 0.1, and then 0.1. The next one is 0, so 0.0, and the last one 0.2. Now you have all 5 of them, and because you are going to record the modulus value, the positive value, so you ignore the negative sign. Okay, you ignore the negative sign. So if you notice, the values that I record in the first column come with 1 decimal point, 1 decimal place, because of the uncertainty here, 0.1 cm in the header. Okay, so make sure, even though you got a round value, okay, a whole number, it comes with 1 decimal place. Okay, it comes with 1 decimal place. And then here is the uncertain, is a average value minus the measure value. Okay, so what does this formula mean? Okay, this formula means just the average, okay, average of this modulus value. Okay, so you add up all of them and then you divide by 5. It would be your delta L. Okay, it would be your delta L. So there are 2 types of delta in your report. Okay, the first delta is from the measuring apparatus. Okay, it's from this, it's for here. So the first delta L actually is for the header. It's a plus minus 0.1 cm, where you obtain it directly from the measuring apparatus. The second delta L, it comes from average value because you take repeated reading. Okay, the second delta L, it exists because you take multiple reading. Therefore, this is a delta L for average value. Okay, actually it should be delta L with a bar on top of it. So the second delta L, it comes from repeated reading. First delta L, you put it in the header, which comes from the measuring apparatus. Second delta L is the delta L for the average reading. Right? It's the delta L for average reading. So repeat step 2 for another one object with different size. That's why you need 2 books, okay? 2 books with different length. So actually this one you should have up until 4 table, okay? So book 1, book 2, over object, and then dumbbell, okay? And then dumbbell. After that, you determine the percentage of uncertainty for each set of reading. So you don't need to measure for each of a measurement. Okay, you just use the average value. Okay, you just use the average value to calculate the percentage of uncertainty. So it's delta L average over L average times 100%. Okay, times 100%. Okay, so this is the website. Okay, this is the website that you need to use for over object and also for the dumbbell. So for over object, you're going to use micrometer screw gauge, and then for dumbbell, you use vernier caliper. So you can either click on this link to proceed to the website, or you can scan this QR code. Okay, you can scan this QR code. So one for over object, and then one for dumbbell. So remember, the things that you need to record when you do the experiment is the measurement with uncertainty of the tools. Okay, measurement with uncertainty from the tools. And then you put everything in the table. So you have a table here. Okay, so this is your measurement. And then this is your delta. This is not delta, sorry. This is a modulus value. Okay, so remember this part, it must come with uncertainty of the measurement. Okay, for the first column. So you record the uncertainty of the measurement, and then you record the reading 1, reading 2, reading 3, up until 5. And then you calculate the difference in the average value and the measure value. We record it here, 1, 2, 3, 4, 5 again. And then you calculate the average value. Okay, average measurement, average uncertainty. And then as a proof, okay, since you are not doing in actual lab, you need to take a screenshot. One screenshot for over object and one screenshot for dumbbell. Okay, and then you paste it in your report. All right, you show it in your procedure. Procedure 5, procedure 6. Okay, procedure 5, procedure 6. So for task 2 and task 3, okay, so experiment step 5, you just paste a picture, okay, a screenshot from the website. Okay, how you do the experiment, how you conduct experiment. So one screenshot, at least one. You want to put more, of course, go ahead. Okay, at least one screenshot from each experiment. Okay, from each experiment, each website. And then attach the pictures in your lab report. So this one, you do it. Now, if you cannot access a report and you cannot access a website, you can go to these apps. Okay, you can go to this app. But this is only for Android though. For those of you who use Apple, then you have no choice but to go to the website just now. For those who use Android, okay, you can come to these apps. You can download these apps in your phone. Okay, so inside these apps, it comes with a vernier calipers and also micrometer screw gauge. But I would prefer you guys to use the micrometer screw gauge and the vernier calipers in these two websites. Okay, unless you truly cannot access this website, then you proceed to the apps. Okay, so this is your first experiment. Okay, that is the end of the first experiment. Okay, so this is the apps that you have to use. The first icon and the third icon. If you use app, okay, first and the third. And then, yeah, that's it. Okay, this is the additional information. It is up to you whether you want to read or not. All right, so that marks the end of the first experiment. Okay, so I showed you how to do the lab report already, how to how to conduct the first experiment. You can straight away start this experiment right after this class. You don't have to wait until next week. Okay, so far, any questions before I proceed to the significant figures and the meanings of uncertainty? If you have any questions, you can just switch on your mic and ask, or you can post in the chat. Okay, you can post in the message. Any questions so far? Hello, any questions?
No, madam.
I guess no, madam.
You can understand, right? How to do experiment. So which lab report which lab manual to use?
E-lab report.
You got 2 lab report, yeah? Make sure you know which one to use in your first experiment. All right, so if no questions, then I will proceed to the next part. Okay. So the lab report in books or in a test pad. Okay, now you do it in the test pad. Okay, you do it in test pad. So the screenshot, you just edit it into a test pad. Okay, after you finish the experiment. Okay, you do it in a test pad, you scan it, and then I will tell you where to upload it. Okay, you must do it in the handwriting form, because that is how you're going to do your report, your final report writing. So make sure you get used to it, and make sure you can finish the report writing in 1 hour. Okay, because in your official exam, the report writing test, you have to complete 1 whole lab report in 1 hour, from a title until the conclusion. Okay, from title until the conclusion. Okay, now significant figures, that will be our main focus today. Okay, because it is very important in your calculations. You need to know how many significant figures to use in your calculations. So what is significant figures? The numbers of significant figures is the numbers of digit whose value are known with a certainty, which means it is a value that come with a meaning. Okay, so for example, if we say it is roughly 80 km between 2 cities, then the numbers that come with meaning is actually just the 8. The 0 has no meaning because it doesn't represent an actual value. Okay, it doesn't represent an actual value. We just round up the values to 80 km. So the one that has meaning is just the number 8. So in this case, we say it has only 1 significant figures because only 8 come with a meaning. 0 is just acting as a placeholder, just to tell us this is 80, not 8, not 8,000, not 800. Okay, so it is 80. So 0, it just tells us this is 80. But the value that comes with meaning is number 8. 0 has no actual meaning because it doesn't represent any actual measurement. If we say it is 80 km within an accuracy of 1 to 2 km, then this 80 has 2 significant figures. It represents the actual measurement. Okay, it tells you the actual distance between these 2 locations is 80 km. Okay, so it is exactly 80. It is not 79, it is not 81. Okay, we doesn't round up the value. So we measure the value and we got an exact value which is equals to 80 km. Therefore, in this case, we say it is 2 significant figures. Okay. Now, if we say we measure something, okay, which is precisely to 80 km, but it comes with an uncertainty plus minus 0.1, then what does it mean? It means the actual value is 80.0 km. Then in this case, we say it is 3 significant figures. All right. So this shows the difference between these 3 values. Okay, we have 80, 80, 80.0. But the first one is just 1 significant figures because we round up the value. Maybe the exact value is 79 or maybe the exact value is 82. But we round up to 80. So the one that has meaning is just 8. The second one is that we measure the value and we got exactly 80 kilometer, okay, with an accuracy 1 to 2 km. So the accuracy is also a whole number. Therefore, we don't need to add decimal point here. For the third case, okay, we say it has an accuracy 0.1 kilometer. It means that we can measure the distance up to 1 decimal place. So the values that we record must come with 1 decimal place, and therefore this value has 3 significant figures. Because our tools can measure up to 1 decimal place, so we can get the exact reading up to 1 decimal place. So that is the difference between these 3 80. Okay, between these 3 80. Now, how do we identify the numbers of significant figures then? There are 4 rules that you have to keep in your mind. First, non-zero value, non-zero digit, they are always significant figures. Okay, means from the value 1 until 9, as long as you have the numbers, then they are all significant figures. Okay, because if you don't know the value, then you cannot write the numbers, right? Therefore, any non-zero digits, they are always significant figures. Final or ending 0, written to the right of decimal point, they are always significant figures. Okay, they are always significant. Now, what does it mean? Okay, if you look at the example just now, if I write this value as 50, this 0, it could be significant figures. Okay, it could be not significant. But if I put a decimal point here, then this 0 is always significant. Okay, so it makes a difference with a decimal point. That's why you cannot simply put decimal point in your reading, because it will change the significant figures in your results. So 50, the 0 here, it could be significant, it could be not significant. Depends on how you record the reading. But when it comes to when it has a 1 decimal point here, then this 0 is definitely a significant figure. Okay, this 0 is definitely a significant figure. But then, if you look at third case, zeros written on either side of a decimal for the purpose of spacing, okay, or we say for a placeholder, then it is not significant. So for example, now I have 0.050 here. The 0 in front of digit 5 is not significant because it's just acting as a placeholder. Now, what does it mean by acting as a placeholder? This 0.050, it can be written as, okay, 5.0 times 10 to the power of 2. Means that you can actually throw this 20 in front of 5 away. Okay, you can throw this 20 away. Therefore, we call it placeholder. Okay, we just use it to keep this place. So with or without it, it won't change the values of 5. Okay, the value is still 5, just that it's 0.05. All right, so the 0 in front of 5 is not significant, but behind 5 is a significant. Therefore, you cannot simply add 0 in your reading. Okay, you cannot simply add any 0 in your reading because it will change the significant figures in your results. So 0 written on either side of a decimal for purpose of a spacing or acting as a placeholder, they are not significant because your actual value can be written in this form. So with or without 0 in front of 5, it doesn't matter. Okay, now number 4, 0 written in between any significant figures, you don't have to think, they are definitely significant. Okay, they are definitely significant. So if you have any 0 in between any significant figures, for example, examples given here, 505, so the 0 in between them is definitely significant. Otherwise, you won't be able to get the last 5. Okay, the reasons why you get the last 5 here, because you know the exact value is 505. So this 0, it comes with a meaning. It represents an actual value. Okay, it represents an actual value. So these are the rules for identifying significant figures. And you must know all of them because it will be tested in your practical test. So practical test, we will always check your significant figures. If it is wrong, then 1 or 2 marks will be deducted. All right. Now, how about calculations? So in your calculations for multiplications or division, often you need to multiply or divide the value in your calculations. Then what are you going to do? You calculate the numbers, you take the numbers with a fewer significant figures. Okay, you take the numbers with a fewer significant figure. So for example, now you have three different values here. 0.745, this value come with three significant figures. 2.2, this value, it comes with two significant figures. 3.885, it comes with four significant figures. So you have three values with three different amounts of significant figures, 2, 3, and 4. So in your final answer, okay, the result, you choose the one with fewer significant figures. So 2, 3, and 4, the lowest value, the smallest value is 2. So your final answer, okay, must come with two significant figures only. You round up the value. Okay, you round up the value. Kamu bundar menjadi dua significant figures. Sebab bila kamu tengok tiga nombor sini, 0.745 dia ada tiga significant figures. 2.2 dia ada dua significant figures. 3.885 dia ada empat significant figures. Antara tiga nombor ini, dua punya significant figures paling kecil, iaitu dua significant figures. Okay, jadi jawapan kamu mesti bundar kepada dua significant figures. Okay, so that is the meanings of you round up to fewest significant figures. You look at all of the values in your calculations, and then you choose the one with the smallest significant figures, fewest significant figures. But when it comes to addition or subtraction, we don't look at significant figures anymore. Okay, we look at the numbers with largest uncertainty. Means that you look at the numbers of decimal place. Okay, so first value, it comes with 3. Okay, means that this measuring apparatus can measure up to 3 decimal place. Second value, it comes with 1 decimal place. And then the third value, it comes with 2 decimal place. When you look at all these three values, okay, this one, 3 decimal place, is most accurate. Okay, because it is very sensitive. You must have a very sensitive tools in order to measure the reading up to 3 decimal place. And then this is 1 decimal place. And then the last one is a 2 decimal place. Okay, so this one, it can measure up to 2 decimal place. So when you compare these three value, the one that is least accurate, okay, or we say it comes with the largest uncertainty, is the one with 1 decimal place. Okay, the one with 1 decimal place. Therefore, our final answer, it just come with 1 decimal point. Okay, 1 decimal place, 1 dp here. So you look at which one is a least accurate, or it comes with largest uncertainty, then our final answer, we follow that one. Okay, final answer, we follow that one. So for multiplications or division, we use significant figures, but for addition and subtraction, we look at decimal point. Okay, how many decimal point in our reading? So take note, okay, take note. This is very important in the calculation part. Okay, in our calculation. Okay, now I keep telling you guys about uncertainty. So what does it mean by uncertainty? So not every measurement is absolutely precise. Okay, no measurement, no, okay, zero. Because every tools, it comes with a limitation. It comes with the smallest value that can be recorded. But in reality, the values, maybe the accurate value can be measured up to infinite amounts of decimal point. Therefore, we say no measurement is absolutely precise. It is impossible. There is always an uncertainty associated with every measurement. So among the most important sources of uncertainty, okay, are the limited accuracy of the measuring instrument, okay, and the inability to read an instrument beyond some fractions of the smallest division. So for example, okay, in this diagram, if you look at this value, you have 0 until 5. Okay, so every smallest division, it represents one reading. So the ammeter in this diagram, it shows the reading somewhere near the 3, but it is not exactly 3. But because we don't have any smaller division in our measuring apparatus, therefore you cannot simply say the reading is 3.9, the reading is 3.8, cannot. You must follow the scale in the measuring apparatus. Okay, you must follow the scale in the measuring apparatus. Therefore, what you can do is you just write it as 3. Okay, you just write it as 3 ampere. But if you look at the diagram, it hasn't reached 3 yet, but you don't know whether it's 3.9, 3.8, or maybe it's even 3.95, you don't know. Therefore, we say this value, it comes with uncertainty. Okay, therefore, when you record the value, you must record it with a uncertainty. So plus minus. Okay, plus minus. So the uncertainty of measurement depends on the type and how it is done. The usual way to express the errors is to write the result in this form. Okay, this one I mentioned it just now. So for example, if you measure the length of the book as 10 cm and you use meter ruler, so the meter ruler, it comes with uncertainty 0.1 cm. So therefore, the value record is 10.0 plus minus 0.1 cm. Okay, so this is the length of your books, and then this is the uncertainty comes from your ruler. Okay, this is the uncertainty from the ruler. Now, if you use a ruler with a 0.2 cm uncertainty, then you just record it as 0.2 cm. Okay, you just record it as 0.2 cm. It all depends on your meter ruler. Okay, on your ruler. So the length that you measure, the uncertainty from the apparatus that you use, and then the unit. This is the ways to record reading in your physics lab. Okay, so let's look at the example. If a measurement of length is found to be 3.24 cm with an uncertainty 0.02 cm, then in your report, you should record it as 3.24 plus minus 0.02 cm. Okay, the decimal point must be consistent. Excuse me. So what does it mean by must be consistent? If your uncertainty is 0.02 cm, then all the recorded value, okay, all the measure value must come with 2 decimal point. If your uncertainty is 1 decimal point, then all the measure value must be recorded in 1 decimal point. Okay, so if you have 2 decimal point, for example, then every measure value must come with 2 decimal point. Sometimes you can have up to 4 decimal point, especially when you use maybe a weighting scale. I think weighting scale you can have up to 6. Then your measure value must come with 6 decimal point. All right? Okay. And then after you record everything, you calculate the percentage of uncertainty. This one I already mentioned it just now as well. Okay, so a measurement with a smaller percentage of uncertainty is more accurate. Okay, we want it to be as small as possible. Oh yeah, I forgot to mention one thing. Now, just now when it comes to books, most of the time students got a 0 delta average. Okay, your delta L average is often equals to 0. All right, it's often equals to 0.0. But in your final reading, okay, if you got 0.0, in your final reading, you have to change it into the smallest uncertainty, okay, the uncertainty in your measuring apparatus. You cannot leave it as 0. So your final reading, for example, in the table just now, the table just now. So in this table, if your delta L bar is equals to 0, then you have to rewrite your answer. Okay, average L is equals to, okay, let's say 10.1. Okay, the value that I obtained just now, 10.1 plus minus, then you have to use this delta L plus minus 0.1 because it is impossible to get 0 error in your measurement. Okay, it is impossible to get 0. So if you obtain 0, okay, especially when it comes to the length of the books, most of the time students obtain 0. Then in your final reading, you change it to 10.1 plus minus 0.1. You use this value, okay? You use delta L value, not delta L bar. All right? So this is the part that you have to take note. Okay. Only in this experiment, okay? All the other experiment, this won't happen. It won't happen. So only in this experiment. Okay, now let's look at the method to determine the uncertainty for single reading. So in the experiment just now, okay, no, not here. In the manner just now, I did mention there are two types of readings that you can get. One is a single reading, which is the readings that you get directly from the measuring apparatus. Okay, from the measuring apparatus. And then another one is a repeated reading, which is the average value. Your first experiment is more on a repeated reading, okay? But of course, you have to take note about single reading as well. So when it comes to single reading, there are three methods to determine the uncertainty for single reading. The first method is what we call single point reading, okay? What does it mean by single point reading? For example, you look at this diagram. You just record the value at one position. Okay, you just record the value at one position. It always begins with 0 here. Okay, it's always start from 0. You don't even have to know where is 0. You just place your object close to this starting point. Okay, then it starts from 0. Okay, it starts from 0. So in this case, because you're just record the readings at one point, so we call it single point reading. So for single point reading, the uncertainty is half of the smallest scale. So if the smallest scale is 0.1 cm, okay, in this apparatus, then the delta x would be 1.2 times 0.1. Okay, if the smallest reading on the scale, which is the sensitivity, if the sensitivity is 0.1 cm, then the uncertainty is just 0.05 cm. All right. So you don't have to record, you just place it to the end now. This one, you don't even have to know where is 0, because actually, if you have this ruler, you will see that actually there is a stopper here. Okay, dia ada satu penghalang di sini. So kamu terus bagi kamu punya objek dekat dengan ini punya penghalang, okay, stopper di sini, then straight away you know this is 0. Okay, you don't even have to record it. If you use meter ruler now, this is a very common sin mistake. If you use meter ruler, okay, so some meter ruler, the edge start from 0. Okay, the edge start from 0. And then you put your object close to the edge. Okay, close to the edge. You record 0 and then you record the reading here, maybe 5 cm. Okay, you put the object near to the meter ruler. You record the 0. You record 5. This one, it is not single reading. Okay, it is not single reading because there's nothing to stop the object at the 0 here. You are the one that determine where is 0. Okay, you got it? You are the one that determine, you place the object here, you tell the object this is 0. Okay, this is 0. But you are not sure whether you place it at the correct positions. Maybe it could be slightly more than 0. It could be slightly less than 0. But you can't tell. Because first, the limitations of the two. Second, the limitations of you as a human. So you don't know whether you place it exactly as a 0 here. It could be slightly more. It could be slightly less. So in this case, we say it is 2-point reading. Even though you know it starts from 0, but because of various limitation, because there's nothing that can tells you it starts from 0, exactly 0. Therefore, you cannot assume you place the object at 0. Okay, you cannot assume. It is unlike the first case where there's something that stop your object that can be used to mark as a starting point as a 0 here. When it comes to meter ruler, even though you place the object at a 0 and then you record just one reading, but this case we call it 2-point reading. So how to calculate the uncertainty for 2-point reading? You use delta x equals to 2 times half of the smallest value, which means actually it represents the smallest division. Why? Because you make error twice. You make the first error at the first reading, second error at the second recording. Okay, you make first error at the 0 cm, okay, your first error, and then you make a second error at the 5 cm. So you make error twice. So you make error twice, therefore we times 2. Okay, therefore we times 2. So 2 times half of the smallest divisions of the scale. That is how you record the uncertainty for 2 points reading. Most of the times we use 2 points reading in our lab, okay, because most of the apparatus that we use, you have to record the positions of a 0 cm, 0 ampere, okay, and then you record the second reading, the final reading. So you record 0, you record final reading. You record 0, you record final reading. You make mistake twice. Therefore, we say the reading taken in a physics lab, most of the time it belongs to 2 points reading. Okay. Now, if an apparatus has a vernier scale, okay, or we say it has a digital scale, for example, digital weighing machine, digital stopwatch, or the vernier scale, then we just take the smallest division. Okay, we just take the smallest division as our uncertainty. All right. So vernier scale, you can find it in your vernier caliper, your micrometer screw gauge, okay, and also all the digital scale. Then we take the smallest divisions of the scale. You don't have to know whether it's a 1 point or 2 point. Okay, you just take the smallest division. So this is a repeated reading. We discussed it just now in the first experiment already. Okay, and then uncertainty for a straight line graph. Now you look at these equations. Wow, it's so scary, right? Don't worry. We got the Excel sheets for you. We put in all the equations already. Okay, all you have to know is how to use the Excel sheets to calculate the delta M. So combinations of uncertainty, now this one I will leave it first because it is hard to explain it without an actual example. Okay, so I will discuss it with you in a second experiment, okay, in our experiment 2. So this is slightly more complicated, especially when it comes to readings where you have to combine few measurements that has an uncertainty together. Okay, so for example, you measure the length of the books, you measure the width of the books, then you multiply the length and the width to find the area. Then you have two uncertainty, right? Then we are going to see how to join them in a final answer, how to join both uncertainty in your final answer. So this one, we will leave it first, okay? I will explain it in experiment 2 until experiment 6. Now this one, okay, this one is a slightly higher level. Sometimes we cannot follow the significant figures or the decimal place, the decimal point rules that we discussed just now. Okay, sometimes you have to look at the value and then you use some common sense to determine whether you want to use 1 decimal point or 2 decimal point. But of course, this one belongs to a higher level. Okay, so it's just an extra knowledge for you. You don't use it in matriculations. Okay, you don't use it in a matriculations report writing. This one, just for your own reading, just an extra knowledge. You don't apply it here. All right, even though this is a correct things. All right, so in the matriculations, we don't look at it yet. So far, any questions regarding significant figures and uncertainty? Berkaitan dengan significant dengan uncertainty, ada apa-apa pertanyaan atau persoalan? Masih hidup kah? Atau kesemua 28 orang dah pengsan dah?
No, madam.
No, madam.
Oh, macam ada 2 orang je kelas ini. Yang lain ada masalah tak? If you
No,
cannot
madam.
switch on your mic,
No.
then you just post in the message. Yang tak boleh buka mic punya, post dalam message. Any questions? I want to see how many of you are still with me. Come. Yang tadi buka mic punya macam dalam 5 orang. Yang message punya dalam berapa tengok. Sekarang no madam, nanti bila buat eksperimen, bila buat lab report, jangan semua salah ya. Because next week, practical class, we don't have any online sections. You're supposed to carry out the experiment in your own house and then submit lab report. That's it. Okay. So dalam message, kita ada 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19. I think we have altogether 30 in the class. Okay, so I want you to post a yes or no in the chat as an attendance. Okay, as today attendance. So yang belum post punya, post sekarang. Kalau tak post, bermaksud anda tak hadir. Six, 28. Yes, 28. So we got 2 missing. Never mind. All right, good. So vernier caliper. Okay, so vernier caliper, this one, I will leave it to you. Okay, I'll leave it to you. I will give you this handout. So you go through it by yourself. Okay, you go through it by yourself. The most important thing is to know how to find the zero error. But unfortunately, because we are not in an actual lab, so all you have to do, all you can do is to go through the notes here. Okay, all you have to do is to go through the notes here. We cannot do it hands-on to determine what is a positive zero error, what is a negative zero error. But you will need to know this one for your SEM 2 though, because SEM 2, you're going to have an actual lab already. You're going to come back to a KMPP, you're going to carry out all the experiment in the lab, you have to know how to use all this. So this handout is very useful, okay? This handout is very useful. So you go through the notes by yourself. Okay, I'm not going to go through it with you. You try to read it, try to understand it. Okay, I'll give you some works to do. So you do it, okay, you read it, you try to understand it, see whether you can get a reading that is same as the example given here or not. Okay, and one more thing here, don't follow the accuracy given in this note. Okay, so if you look at the notes here, it tells you the accuracy of the micrometer screw gauge is 0.01 cm, 0.01 mm. This one is just based on this diagram. All right, this one is just based on this diagram. You cannot follow the accuracy given in the handout because it depends on the tool used in your lab. So for example, the vernier caliper here, it tells you the accuracy is 0.01 cm. But in KMPP labs, the accuracy of a vernier caliper is actually 0.02 cm. Okay, so it depends on the tools given. It depends on the apparatus that you use. Some lab, they have a vernier caliper with a 0.01 cm accuracy. Some, they have 0.02. So this one, you have to enter the lab, look at the apparatus, then you will know which one to use. Okay, so for the virtual vernier caliper, you also have to identify whether the accuracy is 0.01 or 0.02, or it could be even 0.05, all right? So I will leave that one to you. So this one, I won't discuss it. This one, I will give you the handout, okay? And then you try it hands-on in the website, okay? You try it hands-on, you try it with these examples, with this given example first, and then you do it hands-on. Then you will know how to read it. Okay, and then next one, I'm going to look at pre-lab. So pre-lab is some things that you have to do in every lab sections, okay? In every before every experiment. It helps you to get a better understanding in the experiments that you're going to do, okay? Especially in terms of the concept and so on. So I will go through it quickly. This one is also your homeworks, okay? Pre-lab is your homeworks, and then vernier caliper, this one is the additional works that I give you. So pre-lab experiment 1, measurement and uncertainty. I believe this handout is already in your Feeboard as well, in your Telegram as well. Okay, so you go and download it or open it to try it out. Introduction. So complete table 1. Now this is just a revisions of what is the SI unit, and now what is a suitable measuring instrument. Of course, you can have more than one answer, nothing wrong. Okay, you can have more than one answer. And then what is the tools that you use to measure diameter of the coin? Try to imagine, try to think. Okay, so of course it won't be a meter ruler, because if you use a meter ruler, you don't know where is the diameter. So you try to think which apparatus is more suitable to be used to measure the diameter of a coin. And then you have a micrometer screw gauge. Okay, and a micrometer screw gauge is usually used to measure, okay, what is the things that you measure? And you just write it down. Okay, so all this you need to have a basic understanding to do it, okay, to use it. So what is the uncertainty of the measuring apparatus? Okay, you just zoom it in to check it out. Okay. So state the two types of reading. So what are the readings that we can record? So in your first experiment, just now we have seen, we have a single reading, and then we have a repeated reading. Okay, we have a repeated reading. So in single reading, we have 1 point reading and we have 2 points reading. So don't get confused, okay? Don't get confused between all these reading. So single reading is the readings that you get directly from the measuring apparatus. Repeated reading is the average value. And then what is the equation? So equations can also be found in your lab manual. So now this part, okay, starting from this point is for your experiment. So complete table 3. So table 3, what is the measuring instrument that you use? For books, for the oval object, and then for the width of the square object, okay, the diameter of a spherical object. And then what is the uncertainty or the smaller scale, the types of the reading. So whether they are single point, 2 point, or vernier scale. So this is just an exercise, okay? So pre-lab, actually, you don't have to submit, okay? You do it, and then I think they will post the result in a Telegram as well after this week, I think, if I'm not mistaken. So you don't have to submit it as well, okay? You will get the answer. But make sure you tried it out, okay? You tried it out, you check if everything is correct, then that means you understand this experiment. If not, okay, if not means you will have some misconception, then you can ask in the group. So calculate, okay, all this I have go through with you just now. How to complete this table is a very good exercise for you to do before you do your actual lab report, and then express your answer in the form of D plus minus delta D, calculate the percentage of uncertainty. So all these things, there are things that you need to put in your observation, okay, in your observation. So list 3 precautions of the experiment. So you try to imagine if you conduct this experiment in an actual lab, then what are the errors that you might have, and how did you overcome it? Okay, how do you overcome it? Now the precautions, okay, precautions. In my class, I want something that is more specific. For first experiment, of course, you can write 0 error, you can write parallax error, and so on. Okay, but for the following experiment, I don't want to see all this error anymore, because 0 error and parallax error can be used in every single experiment. All right, so keep that in your mind. I just want it in your first experiment. I don't want to see it anymore after today. Okay, after this first experiment. And when it comes to precaution, give me something. If people read your lab report, then they know what to do to overcome the error. Okay, don't give me something like, for example, okay, we need to avoid 0 error. That is not precaution. The precaution is something that people can actually follow your instruction. You give people instruction. Okay, for example, you say, okay, we need to subtract the 0 error, or we need to add the 0 error in our reading. Then I would call that precautions. Okay, you add or subtract the 0 error from the measuring apparatus. That is precautions, because people know what to do based on the instructions given by you. Okay, based on the some things that you write in your lab report. But if you just tell the people to avoid 0 error, then how are they going to do it, right? So you need to give something that people can actually carry out based on your report, they can actually do based on the instructions that you give. Okay, so for example, parallax error. Quite often students tell me we need to avoid parallax error. But how? How to avoid, right? So you give some things people can actually follow and do it after they read your experiment. Okay, don't just tell me we shouldn't do zero error, we should avoid this, we shouldn't do this, we shouldn't do that. No, that is not precaution. Okay, that is not precaution, because you doesn't propose any solution. You doesn't give me any, you didn't give me any solution. Okay, so remember, precaution, you give me something that I know what to do if I read your lab report. Okay, you don't just give me a statement, say we shouldn't do this error, we shouldn't do that error. Then how am I going to overcome that error? I don't know. All right. So don't do that mistake in your lab report. Okay, I see that very, very often in your students' report. So precaution, give something more solid. Some things people know what to do, how to do if they read your lab report. All right. So if you're not sure, you can use this as an exercise. You write it. Okay, you give me the error first. Okay, you give me the error, and then you give the precaution. Then I will tell you whether your precaution is acceptable or not. All right. So even though here it just says list the 3 precaution, but if you want me to check, okay, I will give you a platform to submit your works after this. If you want me to check, then you have to state the error. You state the error, then you state the precaution, and I will tell you whether it is acceptable or not. All right. So it depends on whether you want me to check or not. So this is your first pre-lab. All right, this is your first pre-lab. You go to the fee board, you download it, okay, and then you do it. And then these 2 things, the significant figures and Vernier Calipers handout, I will give you after class. Okay, now before that, I want to know how many of you don't have the Lima ID? How many of you don't have a Delima ID?
Me.
Okay, you don't have. Other than you, anyone else?
Me.
Okay, Maizato and Aisyah, and then who else? Idiana ada kah? Ya, and then Harif yang tak join dengan Delima account punya. I think there are a few of you who join with your personal account. So all of you, you got your Delima ID? Harif ada kah Harif?
Saya tak ada.
Tak ada juga. So yang join dengan personal account ini semua tak ada. Wenchen pun tak ada.
Tak ada.
Alright. Okay, then I will create a Google Classroom with a personal account. Okay, don't worry about that. Okay, in my class, I'm not very strict with all these small details. So I just want to know how many of you have the account, how many of you don't have the account, so that I know which account to use to create the Google Classroom and so on for you guys. All right. So any questions?
Madam,
Yes?
maksudnya habis kelas ni,
Yeah?
kami kena buat pre-lab as
Yep.
exercise,
Yep.
do lab report and submit.
Lab report actually adalah untuk minggu depan. Cuma sekarang kita kan dah tukar menjadi virtual lab. Bermaksud anda boleh buat lab report, boleh buat eksperimen lebih awal. So habis sahaja hari ini, anda ada sepanjang 2 minggu untuk kamu buat eksperimen lah. So by right, anda sepatutnya buat eksperimen minggu depan waktu 2 jam ini. Tapi disebabkan sekarang dah virtual kan, kamu buat bila-bila masa saya pun tak tahu. So tak ada masalah. Kamu nak start buat sebaik saja kita habis kelas ini, boleh juga. Kamu nak tunggu sampai minggu depan jam 8 sampai jam 10 slot ini baru buat pun tak ada masalah. Boleh faham?
Boleh. Baik, madam.
Okay. So yang jam kedua kita sebenarnya adalah untuk kamu buat pre-lab. Okay, so sekarang kalau tak ada masalah, I think that's all for today. Okay, so you guys may leave the class now and proceed to a pre-lab. So you can do pre-lab. If you have any questions, you post in the Telegram. I will answer straight away. All right?
Okay, madam.
Okay, so you may leave the class now.
Thank you, madam.
Thank you,
Thank you,
madam.
madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.